Alright, so the last page of the notes. Again, super common question on the AP test, which means you will see one on the test in here. We give you a picture, we define G as this thing, and then we can ask all sorts of questions based off of that. Alright, the graph of a function f is defined from -1 to 5, consists of a quarter circle and line segments. Let G be the function given by the integral from 0 to x of f of t dt. Okay, well, before we go any further, like what that means, or one way to interpret that, remember that symbol means antiderivative, but it also means area under the curve, and especially if I've got a geometry thing going on here, it means the area under f from 0 to x. So G is like this accumulated area function. Okay, find G of 0. Okay, so if 0 is in for x, then we put 0 in for x on the other side. So what do we think G of 0 is? 0. The area from 0 to 0. Well, that's not anything. That would be 0. All right, G of -1. Okay, -1 goes in for x, so that means from 0 to -1, f of t dt. What's a little bit fishy about that? What's not quite right about that? Yeah, it's like that feels backwards. From 0 to -1, that's backwards. So let's switch it to -1 to 0, and what price do we pay for switching it? A negative out front. So small price to pay to make it a little more recognizable, easier to deal with. Okay, so that's the area from -1 to 0. That would be the area of this triangle. 1/2 base times height is 1. So G of -1 is -1. Another way to do that without like specifically showing this step is that if you go from 0 to -1, that's backwards, so you get a -1. So some people won't show that intermediate step. They'll just know that going backwards is negative. Right, G of 2 would be the integral from 0 to 2. So that would be the area of that quarter circle there. So let's see, that's 1/4 pi r squared. So that's just pi. And then lastly, the integral from 0 to 5. So that means the area from 0 to 5. And I've already got the first part of the area, like 0 to 2, the area is pi. And then the second part of the area, let's see, there's a triangle, that's a -1. And then this is a trapezoid, but you can avoid the trapezoid because you could just do, you can almost just count them up. Or you could do a rectangle plus the triangles, however you want to get there. That rectangle is 2 and that triangle is 1, so all together is -3. So from 0 to 5, the total area is pi minus 4. By the way, on the test, on Wednesday, the free response day, there's 2 free response questions. They each have 5 parts. Each of the parts is worth 3 points. Part B, find all values of x on the open interval at which G has a relative maximum. Justify your answer. Okay, justify first, right? G has a relative max when, so you can answer this question, you can finish this statement without any regard to this problem or any other problem, how do you know when G has a relative max? Yes, I saw it. What is the calculus words that go with that?
Slope goes from positive to negative.
Okay, that's right. And what's a more calculus-y word than slope? I mean, you're right. When slope of G, also known as G prime, goes from positive to negative. Okay, so I need to know what G prime is. So G prime means take the derivative of G. It's like, oh, we've done this before. The derivative of the antiderivative. So those cancel each other out. Plug in the top one. I guess plug in the bottom one, but the chain rule off of 0 would be 0. So G prime is f of x. And now we can answer, let's see, so where G prime goes from positive to negative, but G prime is the same as f. So I want to know where f goes from positive to negative. So I'll look at my picture. And where does the graph of f change from positive to negative? At 2. So that means G has a maximum at 2. Now, if we back up and try to think about what this represents, we might could figure that out, because G is the sort of the accumulated area starting at 0. So we're adding area up to 2. Starting at 2, we start subtracting area. So it makes sense that 2 would be a max, because we're no longer adding, then we start subtracting. We max out at x equals 2. Part C. Find the absolute minimum on an interval. So already I'm thinking make sure to check the endpoints at which the value of x occurs. Justify your answers. Okay, it's the absolute minimum of G. So I need a table of values with x and G of x. Definitely want to include the endpoints. I also want to include the critical points. But we just found the critical point. In fact, the only critical point is x equals 2. And I'm not sure I really even need to check that one. If you don't check it, you need to say why. Why would I maybe not need to check x equal 2 if I'm looking for an absolute minimum? Because I already know it's a relative maximum. So yeah, it's a critical point, but you could skip checking it because you already know that it's a relative max. Now, the good news is we already found G of 2. So that was in part A, G of 2 is pi. You could also, again, skip finding it. But if you skip finding it, you better tell them why. Because the grader, me, I'll be looking for the endpoints and the critical points. So if you want to skip a critical point, you better tell me why you're skipping the critical point. Okay, G of negative 1, we already found these, is negative 1. G of 5 is pi minus 4. Find the absolute minimum of G. Okay, so which one of those is smaller, negative 1 or pi minus 4? Negative 1. So the absolute minimum of G is negative 1. That's the y value. The minimum is negative 1. And the value of x where it occurs, that occurs at x equals negative 1. So make sure you read the question to know if they're asking for the y value or the x value, and in this case both. And this is a nice one because if you got them confused, it's the same number. Part D. Find the x-coordinate of each point of inflection on the graph of G on -1 to 5. Justify your answer. Okay, justify first. So point of inflection of G this is, again, usually you can make the justify statement without knowing what else is going on in the problem. So how do I justify G having a point of inflection? What would I be looking for? What's the calculus thing that's going on for a point of inflection? What's that? G double prime changes signs. Okay, that's true. It's not quite helpful yet because I don't have anything that tells me what G double prime is. But I do have this statement up here. G prime is f of x. So G double prime then is f prime of x, which is the slope of f. So I'm trying to get things in terms of f, because f is what I know. I've got a picture of f, so I would like to get things in terms of that picture. So I want to know where the slope of f changes signs. So we look at our picture. Where's the first place that the slope of f changes signs? What x value? 0. So at x equals 0. Anywhere else the slope of f changes signs? At 3. So at 0 and 3, the slope of f changes signs, which means f prime changes signs, which means g double prime changes signs, which means we have a point of inflection. Again, pretty common to have a question like that on the AP test. And usually students like that. It's better than a crazy word problem where you're trying to figure things out. Pretty straightforward.